So for those functions that aren't quite as simple as the first ones we looked at, there is an algebraic way to identify the inverse precisely. So finding an inverse, we can look at the graph. We could graph the function. We can use the horizontal line test, and that will tell us if an inverse exists. So then what we do is in our equation, and here's the big thing, we interchange the roles of x and y. So we switch x and y, and then we solve for y. Okay. And then the two steps, the step above and below that are kind of some technicalities. We're going to be given our function in function notation. So we're going to replace that function notation with y. And then after we have solved for y, then we're going to replace the y back into that function notation as our inverse. So the two that I have highlighted, numbers 2 and 4 that I've highlighted in blue and yellow, those are replacing our function notation with y, and then at the end going back into our function notation. The main idea is that we're going to switch, we're going to interchange the roles of x and y, and then solve for y. And then, of course, we can verify using our composition. So let's practice just finding the inverses here. So first example, f of x equals 5 minus 3x divided by 2. So what we're going to do is we are going to replace f of x, which is y. So think about this as y. We're going to replace this with just x equals, and then 5 minus 3, and then we're going to change the x into a y and divided by 2. So the first step is to switch x and y. And now we will solve for y. And that will be our inverse. So if we solve for y, we want to get y by itself, right? We focus in right here. We have the 2 in the denominator. And we know that to get rid of a denominator, you just multiply both sides, or multiply every term times that denominator. So we're going to multiply this side times 2 and this side times 2. So the 2's here will cancel. That'll leave us with 2x on the left equals, and then 5 minus 3y. Remember, we're still focused in on solving for y, so I'm going to move the 5. So let's subtract this 5 because that is a positive 5. So that'll give us 2x minus 5 equals a negative 3y. Still solving for y, I'm going to go ahead and divide everything by negative 3. Divide by negative 3, that'll cancel here. That gives us 2x minus 5 divided by negative 3 equals y. Now this is our inverse. So we're going to go ahead now and switch back into function notation and say that the inverse function of x is 2x minus 5 divided by negative 3. Now, this is a good answer. However, sometimes that negative will not be left in the denominator. We just want to kind of pull that negative out in front. And so the way this could also be written is that the inverse of x is negative, and then the 2x minus 5, and then divided by 3. So either of those are correct. You may see this in an answer key or in books more often, because when you have that negative in the denominator, it's a little bit more proper just to write it out in front. Let's do another example here. So let's go ahead and look at our g of x function. So we can still replace whatever this function notation is, that's your y value. So we're going to switch x and y. So we're going to rewrite this as x equals 3y to the 4th plus 5. And then we're going to solve for y. So we're solve for y here. All right, well, to do that, let's subtract the 5 over first. So that gives us x minus 5 equals 3y to the 4th. And then let's go ahead and divide by 3. So that gives us, I'm going to go ahead and switch this around, y to the 4th equals x minus 5 divided by 3. And then we know that we would do the fourth root to get rid of this x to the fourth. So we could do the fourth root and the fourth root of everything. And that gives us y equals the fourth root of x minus 5 over the fourth root of 3. Now, just like a square root, we don't want to leave that fourth root of 3 in the denominator. So here's how you can get rid of that. So here's kind of a good example to work with. We can still multiply by whatever's in the denominator. So times the fourth root of 3 times the fourth root of 3. That'll give us y equals. Now in the numerator, because both of these terms are underneath the fourth root, we can combine them. So we can write this as the fourth root of, and then we just multiply the 3 times both of these terms. So 3x minus 15. And in the denominator, the same thing happens as if you had a square root. When you multiply two roots together of the same thing, your answer is just 3. So the inverse function here, now that we've solved for y, we can rewrite it as, let me use the proper letter here. I believe this was g. So the inverse function of g is the fourth root of 3x minus 15, all divided by 3. Okay, one more example. So same idea. H of x is the same thing as y. It's just function notation. So we're going to replace y with x. So we're going to write x equals, and then in both of these positions, we're going to change that to a y. So we're going to change it to 5y minus 3, and then 2y plus 5. Okay, now we're going to solve for y. Now to do that, we have a y in the numerator and denominator. So just like in number 1, we want to get rid of the denominator. So multiply both sides by whatever's in the denominator. 2y plus 5, 2y plus 5. So that's going to cancel your 2y plus 5s on the right. On the left, we do need to distribute and multiply both of those by x. So it'd be 2xy plus 5x equals 5y minus 3, that's left in the numerator on the right-hand side. So now there's no more fractions, but we do have multiple y values. So what we're going to do is get the y values on the same side. So the two terms that have y is this 5y and then the 2xy. So let's get those on the same side. I am going to move this and subtract the 5y over. And so then I'm also going to move this and subtract the 5x over. So I'm going to do two things at once. So that's going to cancel out the 5x on this side, and it's going to cancel out the 5y on this side. So we're left with 2xy minus 5y on the left, and then the negative 3 minus 5x on the right. And remember, our focus is still the y value. We're solving for y. And because both of these terms have y, we can factor it out. So if we factor out the y, that leaves us with 2x minus 5 equals negative 3 minus 5x. And then to get, remember our focus, get y all by itself, we'll divide by this 2x minus 5 and divide by 2x minus 5. And there we have, so those cancel, that's our y equals. Now I'm going to go ahead in the numerator here and write this in standard form. So I'm going to write it as negative 5x and then a negative 3. Either way is correct, but you'll see standard form in the answer key. And then 2x minus 5 is the denominator. And now that I have that, this is my inverse. So the inverse function of h should be negative 5x minus 3 over 2x minus 5. So there are a few examples of finding the inverse using algebra, where you just switch your x and y and then solve for y to get your inverse. Here are your practice problems from lesson 2.7. They're all odds, so you can check them all. Please make sure you do. And as always, please make sure that you ask any questions if you have any.